I'm Daniel Weck. I'm a software developer. I work with EDRLab, where I help implement the LCP specifications. I also contribute to the Readium open source development. In addition to this, I work with the DAISY consortium, where my focus is a bit more on accessible open standards, accessible production tools, and reading systems. But now I'm going to talk about Thorium, or Thorium in French, which is the desktop reader app made with the Readium SDK. So Thorium is available for Windows, Mac, and Linux as a standalone installer, as well as deployment on the relevant app stores. It is free, as in free of charge. It's also free, as in open source software. I'll give you a link at the end of this presentation on GitHub, where you can find the source code. And it's developed primarily by EDRLab. So just as a teaser, this is a screenshot of the bookshelf view, and that is the reader view of Thorium. So a couple of key features, enough to fit in a slide. There's a bit more to talk about, but in a nutshell, Thorium's user interface is accessible to people who have blindness, low vision, or dyslexia. So we aim very hard to implement robust support for keyboard usage, screen readers compatibility, and things like high contrast mode. The bookshelf is organized using publication metadata, as well as user-edited tags, sort of textual labels that users can associate with their publications. And this enables things like sorting, filtering, searching, and so forth. The text layout, formatting of the actual content documents from publications is customizable. We have support for text-to-speech, TTS, for a read-aloud playback experience. We support bookmarks, annotations, highlights, and a few other things. EPUB is, of course, the primary standard that the application can ingest, fixed layout, and reflow. Publications can be encrypted with LCP, protected with LCP DRM for library landing, for example. We naturally support OPDS as the primary format to transport information about online publication catalogs. OPDS feeds are great, as you will have heard in these couple of days. We aim to support PDF as well. Audiobooks, although to the extent that audiobooks consumption on desktop platforms perhaps is not as high as a priority as it is on mobile platforms, but we certainly aim to provide support for comic books, manga, and bande dessinée. As you can imagine, on larger screen real estate or extended displays, it makes sense to read richly illustrated material. And ultimately, when the W3C web publication standard emerges out of its current draft status, we'll be ready to implement support for it. In fact, we kind of already do through our support for the Readium WebPub manifest, which shares a lot of similarities with W3C web publications. So for those of you who are technologists, under the hood, we use the Readium Desktop SDK, what we internally call Readium 2, the second generation of Readium SDK. But the app is built with Electron, and at the core of Electron is Chromium. And Chromium is the web browser engine that powers Google's own web browser, called Chrome, as well as the upcoming replacement for Edge. So Microsoft is working on a replacement of Edge that will be based on Chromium for their Windows 10 desktop operating system. And the reason I mention this is because we don't only use Chromium to render the book contents, we also use Chromium to render the user interface. So we use web technologies to implement the user interface that you will see in the screenshots that I'll show you later on, which means HTML, CSS, SVG, JavaScript. What that means is that the techniques that we use to make the user interface accessible to keyboard users, to make it compatible with screen readers, are the same techniques that web developers use. Those of you who are familiar with web development will recognize React. This is the framework we use to put together the user interface in Thorium. Although we do use our in-house custom components, we have decided to create our own accessible controls. We don't depend on an external library for this. And lastly, for our store management and our state infrastructure, we rely on a set of technologies that, again, you might be familiar with, so Redux, Saga, and some database. Again, web technologies. So for those of you who may think that because it's a desktop app, it's built with some proprietary platform-specific technology, it isn't. It's cross-platform, and it's mostly web technologies. So if you feel like you can contribute some of your expertise, you certainly may. This is work in progress. We have a beta release available for public testing. So when I mentioned earlier on that there are installers available for Linux, Windows, and Mac, as well as App Store's deployment, I wasn't lying, but it is in preparation. It is in beta testing at this stage. Microsoft is helping us deploy our first beta into the Windows App Store. We're looking at the challenges related to Windows 10s as well, which is sort of a more stricter sandbox for apps, especially suited for the education sector. We know we have a number of challenges to solve, but it's good to have Microsoft's help on this case. We're striving to improve screen reader support. So we aim to support Narrator, which is Windows's native screen reader that ships with the operating system, but also NVDA, the open source alternative, JAWS, the commercial one, and on Mac, of course, we aim to support VoiceOver. We're currently fixing user interface bugs, so if you download the app and notice some of these, feel free to either report them in the issue tracker, which I will give you the link to later on. And the very likelihood is that we've already noticed them, so we know they exist, and we're working hard on fixing them. We're tweaking the language localization, currently available in English, French, and German. We developers created those localizations, those translations, so they might not be perfect, and we're still tweaking them. All right, so without further ado, let's look at a series of screenshots to illustrate various feature sets. So in Thorium, there is a clear distinction between the bookshelf view and the reader views. The user interface is minimalist to create a distraction-free environment. So that is, as I said earlier on, the library view, very classical visualization of your local library with the cover images, title, and the name of the author, a bunch of menus to give you access to a information sheet that contains additional metadata about the various publications loaded in the library. You can list the publications instead of showing their cover images if you want to sort them by date or by author, the usual features that you would expect in a modern bookshelf. The reader view is equally conventional, nothing too special to report here. So let's move on to the next series of screenshots. Thorium being a desktop app, we really want to leverage the fact that we're going to benefit from a much greater screen real estate, potentially as well extended displays, external displays. So we made it possible to open multiple reader windows. Common use case would be to do comparative book study or foreign language learning by having two different languages side by side of the same book, for example. So that's kind of what it would look like. By default, the application launches in single window mode. We expect that users in the vast majority will read one book at a time, but for those that do want to read multiple books, it's just a click away and it's just very easy. So as I said earlier on, the user interface is localized in English, French, and German. The user interface that we implemented to select languages is very straightforward. No need to restart the app. It's an instant live reload. The bookshelf is organized, as I said earlier on, with customizable user labels. We call them tags, which enable features such as filtering, sorting, and searching. Here's an example of looking at the information sheet for a particular publication. And you can see inside the blue highlighted area that I'm typing in a tag name specific to me as a user, and I add that to the metadata of the publication in my local bookshelf. And as you can see, with the existing tags, they can be removed, and they're shown in blue here. Yeah, showing okay on the display, I'm just checking. And back in the bookshelf, at the bottom of it, you can now see that we have a section dedicated to organizing the tags, which allows me as a user to quickly be able to browse the publications that are of interest to me. We support OPDS, publication feeds, which means that as a user, I can access online catalogs. It looks like this. You can copy, paste, or type in a URL, such as the Feedbooks catalog here, feedbooks.com/catalog.atom. For those of you who are not familiar with Atom, the version 1 of OPDS is based on Atom. It's an XML format used to distribute information about publications. So it's a stream of information, a feed that contains metadata about publications and where to download the actual EPUBs. And if we dive into the new and noteworthy category of feedbooks, we end up looking at a view of the cover images that is very similar to our local bookshelf. So we aim to make the user experience very consistent, so as not to confuse users. And once I've downloaded a book from that feed, if it's a public domain book, it'll be available instantly from this interface. If it isn't, it needs to be acquired separately in a separate activity, such as opening a web browser session and paying for the book and downloading it from a provider. And when I look at the information sheet for a particular book from that feed, I can see that the tags are pre-filled. I can't remove them here. There's no cross to allow me to remove them. They are baked into the metadata of the publishers has decided to add to the publication. But of course, I can still add my own tags if I need to. So in this case, we have tags for fiction, science fiction, adventure, and so forth. So naturally, we support table of contents, EPUB landmarks and page lists, which are features that can be authored by publishers or content creators directly into the publications. And that's how it looks like in the user interface. So the point of this slide, of this screenshot, is to show that the blue highlight that is currently putting some emphasis on a particular table of content heading relates to the fact that I'm using the keyboard to navigate the user interface here. Whenever I use the mouse or any other pointing device, such as a trackpad, this wouldn't necessarily show. It would be probably a hindrance to users who are not visually impaired. But for those that who are not blind but who are visually impaired, low vision, it is very important to give some context and give some feedback when using keyboard interaction. So you will see in future slides and future screenshots how that impacts other areas of the application. So keyboard navigation, not only in the user interface of the application, but also in the documents that we load from EPUBs, HTML documents that we render in the application. So we also highlight hyperlinks that are navigated to using the keyboard inside the document rendering area. And we automatically turn the pages when tab navigation takes users into different sections of the document. So that's how it would look like. Here I have a book with a hyperlink. You can clearly see this visual feedback that it's been focused into using keyboard navigation. And if I were to tab one more time in this particular document, which I'm very familiar with, I know there is a link following in the next set of pages, so that would take me there automatically. The app wouldn't just stay on this two-page spread. It would move to the appropriate next set of pages. The content documents that we render from EPUB publications, their default styling can be modified by users depending on their preferences. So we allow the text layout, text formatting, colors, themes, and typography to be customized. So here we have an example of changing the size of the margins, word spacing, letter spacing, and line spacing. I myself, as somebody who needs to use larger line heights in order to be able to read text, I find that obviously very essential in my reading experiences. We provide support for custom fonts. We have a preloaded selection of fonts, which includes one particular type that is designed to make reading easier for people with dyslexia. It's your typical sort of bottom-heavy font face. We intend to ship support for system fonts. So you'd have different fonts available on Mac, on Windows, and Linux. And actually, from one machine to another, you may have different fonts available on the system. But we want to make sure we expose those fonts in the reading system as well. And potentially, we might, if that becomes a higher priority, we might implement support for web fonts as well, fonts that are hosted on the Google Cloud, for example. The desktop app is really designed to be an offline app, but there's no reason why we shouldn't leverage online features when the user is online. So here's the user interface where I can change the font size and pick a particular font from the available selection. So here's a close-up of what that looks like. We have sans serif, serif, monospace, and the dyslexic font as well in there. Now, at this stage, I should point out and arch back to what Alpha Editor referred to, which is that we're using Readium CSS to power all of these features. It's very important to realize that there is no duplication of code between iOS, Android, and desktop platform, and even the web. We're leveraging a very powerful library that does all that work for us, including specifying what fonts are appropriate for a reliable reading experience across multiple platforms. So all of that stuff is defined in Readium CSS. We have dark mode. Soon the user interface will become dark as well. At the moment, this is a missing feature, so the user interface will be dark as well in a future iteration of the software. But you can see, of course, we have high contrast and dark mode here in the document of the publication. We support pagination, scrolling, two-page spread versus single column of text. That's obviously very important on large displays. I want to be able to customize the way the text looks. Some of us have different preferences. I myself find it very hard to read long runs of text, so I'm very comfortable reading newspapers, which tend to have very narrow columns, but not so much with digital content that's spans across huge displays. So we have all of this in place to provide a user experience that's satisfactory on larger screens. We support pop-up footnotes. This is an EPUB feature. Content creators can declaratively associate behaviors with their hyperlinks. By default, for a reading system that does not support pop-up footnotes, the user clicks on a hyperlink and that will take the user to the end of the document, what would be seen as the bottom of the page, let's say, in a book. And the user would then have to navigate back into the reading location, the original calling site for that footnote. For reading systems like us that do support pop-up footnotes, the original context doesn't change, so the user clicks on the hyperlink and a footnote pops up, literally, as an overlay to the main document. What's special about our implementation is that we're very cautious to implement all of that stuff in an accessible manner. So we have keyboard access to trigger, to activate the link, but we also have keyboard access to read the pop-up note content. We also apply consistent styling to the pop-up note content, which isn't the case with the vast majority of reading systems that I've tested. So imagine you're using large print, dark mode with increased line spacing, and then you click on the pop-up footnote, and it's this just weird small window that pops up completely out of context, and it's impossible to read. So this is how it would look like how it does look like in Thorium. So here the blue highlight indicates that I am about to click on a hyperlink, which is an asterisk next to some German text here. The red arrow here is my annotated overlay, but you can see that the pop-up footnotes appears at the bottom of the page, and it uses the same styling as the text, and it is completely keyboard navigable as well. To demonstrate that, if we increase the font size, change the font face to the dyslexic font, as you can see, the pop-up footnote reflects that styling preference that I've expressed. Thorium obviously supports LCP DRM, so we'll hear a lot more in the next session, a lot more in-depth information about LCP, but it's basically a passphrase. It's a scheme that is based on passphrase-based protection to encrypt resources and to enable scenarios such as book landing. So in Thorium, a typical use case would be to start with a license. It's a very small file, usually with the .lcpl file extension. Very small file, you can read it with your text editor, it's JSON. And what's in there is metadata about the publication that I'm about to download. And it's metadata specific to the LCP license. It contains everything you need. This is totally offline. There's no need for an internet connection at that point. The application asks me for the passphrase. I enter it. The application saves it, so I don't have to enter it anymore. And the book is in the library just as any other books. On this dialog, we can see that a hint is displayed. The hint comes from the license. It's not something that the application makes up. So in every licenses, for every LCP-protected publication, there has to be a hint which helps the user remind what the passphrase is. So I'm getting to the end of this set of screenshots. We have support for highlights and annotations in the test app prototype, and it will come to Thorium very soon. This is how it looks like, nothing too extraordinary here. A few details about our implementation. It works with fixed layout, reflow, both scrolled and paginated. It's DOM-friendly in the sense that we display a transparent overlay on top of the DOM, so we don't interfere with the actual content of the book. We have SVG and HTML rendering. The mark styles that we support are underlined, strike through. We use a JSON serialization format for interchange purposes, and that's compatible with W3C annotations. And last, we support text-to-speech also in the test app prototype. It will come to Readium soon. This is how it looks like. We have word-by-word highlighting to put some emphasis on individual word boundaries. We have breakdown of long paragraphs or long section of text using sentence detection to reduce down each utterance to some palatable granularity at the sentence level. So that's what helps us implement pause and resume as well as previous next. And again, we have customizable styling. So based on user preferences, TTS playback will show the correct consistent settings as well. So last slide. If you want to learn more, go to our GitHub repository at github.com/readium/Readium Desktop. Please do note that this will be moved at some point soon to /EDRLab/Thorium, but you will be automatically redirected, so you don't have to remember that by heart. And of course, go to EDRLab.org to learn more about the other projects.